starting with a panel session in the next 2 minutes, talking about network automation, but more than network automation. The team that's coming up as the panelists are going to talk about some of the experiences they've had as well through their careers growing up and being in this part of the business, and hopefully giving you all some insight into what to do and what not to do as part of your career path going forward. So without further ado, I want to go ahead and introduce Scott, who's going to basically run the panel, and I'll just sit on the side and moderate. Appreciate it. Thanks.
Hi, everyone. How's everyone doing today? Good? All right. I can tell that the lunch has taken a toll on you. All right. I must warn you that if I catch you sleeping, I'm going to call you out. So just be aware. All right. Well, I won't be up here for very long. I'm going to very quickly transition into the panel because they're the real stars here. I have just been invited to kind of moderate and guide a little bit. My name is Scott Lowe. And I'm really, really honored to be able to moderate. This is a great group of individuals here. A lot of them, you probably recognize their names or may have met them in the past. They've all made massive contributions in the areas of network automation and network programmability. Very quickly, I'll just introduce who you have on the panel this afternoon, and then each of them will give you a more in-depth kind of review of their background and their bio and that sort of thing. So we have Kirk Byers with Twin Bridges Technology, David Barroso with Fastly, Jeremy Stretch with DigitalOcean, Jathan McCollum with Dropbox, almost lost that, and then Mircea Ulinic with CloudFlare. And each of them is going to be discussing a particular aspect of network automation. We have some topics on how do you get started with network automation, how do you kind of get going. We'll be looking at various components that you might be leveraging within network automation, from Python libraries to sources of truth back in databases that you will leverage in order to do automation, as well as some other configuration management tools that are all going to be discussed. So there's a nice range of topics, and you've got a great level of expertise here to share that information with you. We are going to save some time at the end for questions, so I would just ask that you hold your questions until the end if you don't mind, and there are microphones nearby, so towards the end we'll open it up to Q&A from the audience, and then you just go to one of the microphones, ask your question, and one or more of the panelists will respond and try and answer your question for you. So to get things started and kick us off, I'd like to introduce Kirk. Kirk, take it away.
All right. So my name is Kirk Byers. I am a longtime network engineer. Can we go on to the... Oh, already screwed up. So can we go... I'm a longtime network engineer. I run a lot of Python courses. I run Ansible courses. I'm a CCIE in routing and switching, emeritus, which means I'm old, and I don't want to take the written anymore. So I also work a lot in open source. I'm sort of the main creator of the NetMiko Python library, and I work quite a bit on the napalm team. And I also occasionally run the SF network automation meetup. So today I'm going to talk about a couple of points on network automation. I'm going to talk about getting started, and I'm going to sort of invert this because I thought it would be fun. I'm going to invert it and say how we could fail. Now, I'm not trying to hammer on negatives because it's very easy to be negative and it's hard to do a lot of things, but I just thought it would be fun and it would probably illustrate some anti-patterns and we can look for positive patterns. And at the end, I'm hopefully going to provide some context of resources you can use and places you can go to actually more proactively get better whatever stage you're at. So let's dive in and talk about how, if we're getting started in network automation, how and what are some ways we can really mess this up. So one pattern that I see is people early on, they try to start with high risk and difficult problems. So as opposed to looking for easy wins that give you a lot of value, they look for something that's really hard, really challenging, and has a lot of risk that you can really cause some serious mistakes. So just to pull one out randomly, let's say we wanted to try to programmatically program routes on the router. For whatever reason, we wanted to pick that problem to solve. Now, that's a hard problem. I don't really want to do that problem. I don't really want to abandon routing protocols and say, I'm going to go and dynamically program routes into my router. So there's much easier wins that you can get instead of that. And the kind of patterns you want to start to look for are what are low risk but time consuming. So if you think about it, operational actions are clearly going to be easier, like information gathering is clearly going to be easier than config. And then even in the set of config, there's going to be certain changes that are much easier than others. There's going to be changes that are a lot higher risk than other changes. So definitely early on, you want to be focusing on low risk, easy, big gains. Now, as across time, you can start expanding and building on more and more things, but don't try to do that at the beginning. So another pattern that I see that is problematic is this all or nothing mindset, where you sort of think, in order to do automation, I have to do everything, that it's an all or nothing. Either I automate my entire environment or I don't do anything. And this is really the wrong mindset to be in. You need to be looking for small parts. You have some big process you're doing, maybe it's 20 steps, automate like steps 3, 7, 9, and across time, keep adding on to it. But don't think of it as, oh, everything's ought to be automated or nothing is. Look for these small incremental gains and then build on what you have. Another anti-pattern I see, and I've fallen into this as well, is you're trying to reinvent everything yourself. There's a lot of amazing, intelligent people that have come before us. They've built a lot of amazing things. Try to reuse the things they've already done. Don't try to go and rebuild what's come before you, if you can. Now, sometimes there's cases you get into where what exists before you doesn't solve your problem very well, and then you can build something new. But especially early on, when you're coming to automation, this is not the problem you typically have. So spend that extra 30 minutes looking around for, oh, what are the solutions available that do X? Can I reuse one of that? Does that use case solve 75% of my problem or not? Another pattern that I see that's problematic is, and this gets into how much programming do you need to know, but the superficially copying things without much comprehension. So I think you're going to have a lot of trouble in network automation if you don't know some amount of programming. Now you can say, I don't want to do anything with automation. You can be over there on that spectrum and you can have a long and successful career. But if you're going to be in automation, I think you're going to need to know some amount of programming. And we could talk about, how much programming you need to know, but you're going to be really, really in a bad situation. You're not going to have a core tool available to yourself that you're going to need to be successful. And I would say this applies if you're using frameworks as well. So I'm a lot more familiar with Ansible than Salt, but if you're using Ansible, if you don't know some amount of general purpose programming, you're going to have some serious difficulties with Ansible. Ansible has 2 programming languages embedded in it. It has its own, and it has Jinja 2. And in many ways, they're very obscure, at least from a syntax perspective. So I think it's probably not naive to think that you're going to get away from programming at all, even using some of these frameworks. What other anti-patterns do we see? So failure to learn good debugging processes. So in my head, I like to word this, always have running code. This is probably the most common pattern that I have. I try to make the gap between when I make changes and when I execute and when I fix it to get back to running code very small. You want a small feedback loop. If you go and write a big amount of stuff and then have to fix all the problems to get it running again, that's problematic. That's pretty hard. I would also add, figure out with whatever you're doing how to get a good feedback loop. Maybe this is just print statements. Maybe it's logging messages. Certain contexts, it's actually harder to get information out of your system. Figure out how to get a good feedback loop. Build upon that. Another anti-pattern that I see is over-engineering the solution. So really ask yourself, how much does performance matter here? How much does this other aspect matter here? A lot of times they don't. Don't solve problems you don't have. Don't solve problems that don't exist. You can really add a huge amount of complexity that is unnecessary in doing that. Okay, so a few other anti-patterns. This is a little bit similar to a previous one. Whenever you learn something new, try to apply it as quick as you can. If you want to retain it, if you want to make it useful in your life, then you need to apply it. Find something small, maybe it's even tangential to what you're doing, apply it in that context. Another anti-pattern is this being too busy to automate. So if you have no time in your work schedule, if you're 120% booked, you're not going to get any extra time to think about how can I make my system, how can I make my processes better across time. I've noticed myself fall into this pattern, and it's not a good pattern to be in, where you think to yourself, I should really spend the 2 hours here, go and add this automation, and this thing would be done. But then you think, I don't have the 2 hours. I just have to get that done. And that's going to happen from time to time, but if that's your constant pattern that's always happening, then you're going to go a year, 2 years, 3 years down the road, and you're going to be in the same exact boat you're in today. You're going to be doing the same exact operational tasks. You're going to be solving the same exact problems. Now, these last two start to get into a little longer term items. So, fail to learn how to reuse your code. And this is definitely a more intermediate skill here. But programming has this amazing capability. You can build these artifacts that you can reuse later. So yes, you can solve that particular problem that you're solving, but you can also build a set of artifacts that can help you solve the next problem and the next problem. And you need to learn how to take advantage of some of these capabilities that any given language, any given programming language allows you to do that. And then a similar item is this failure to use available developer tools. So as you start to do more and more automation, you're going to need to add things like Git and code quality checkers and unit testing and CI tools. These things add some amazing capabilities, and you eventually need to become familiar with them. All right, so that was some ideas on, from a personal perspective, how do people fail. Now I'm going to talk very briefly about devices and some characteristics of devices in the network automation context. So one problem, and I've done this as much as most people, is this problem of we make everything different. We make our configs different. We make our vendors, platforms, OSs different. We make the number of features we're using different. This is going to make automation harder. Now, sometimes you just have to solve the problem you have to solve. But at least have in the back of your head, is this problem, this variation that I'm adding, is it worth this difficulty that I'm going to introduce? The second point here is we, as purchasers of hardware, we need to buy equipment that has a good, usable API. It needs to have 100% feature parity with the CLI. We need to basically get out of screen scraping. I've worked on a screen scraping library. I'm done. I don't want to really maintain it for the next 20 years. We need to move on. And then a few other minor points. Well, not necessarily minor, but a few other points. We need hardware that has a good commit mechanism. We need commit, candidate configs, rollbacks, diffs. We need good mechanics for how to programmatically make configuration changes on a device. And then we need virtual devices for testing. And the bottom one is, I think you're going to have trouble in automation at a given organization if you don't have buy-in from the management and from a lot of people. You can do a certain amount, yes, but I think you're going to struggle if you don't have a larger momentum behind yourself. And with that, I will transition back to Scott.
All right, thanks, Kirk. That's great. Good job. All right, so up next, following Kirk's presentation, we're going to have David come up, and he's going to be talking about napalm. So take it away, David. Here you go.
Hello? That talk was so depressing, Kirk. So my name is David Barroso. I'm a network systems engineer at Fastly. Before that, I was a network engineer at Spotify, which is where the project I'm going to be talking about actually started. So napalm, who is familiar with napalm here? Could you raise your hand? Oh, that's quite a lot of people. Great. So napalm starts for network automation and probability abstraction layer with multi-vendor support. It's basically a Python library that tries to abstract how to operate your networks. I mean, Kirk was mentioning, for example, that if you have like multiple different vendors, like they operate differently. So napalm tries to solve that problem. Like you get a set of methods that manipulate configuration, that get operational data, and no matter which vendor you're dealing with, those methods are going to behave consistently. napalm supports many vendors. Vendors like, operating system like iOS, iOS XE, XR, Junos, EOS, FortiOS, Pluribus. There are a lot of different vendors. It's integrated with SaltStack. There are also integrations for StackStorm, NSOT, Ansible. So you can use it with your own code or with any existing framework out there. And it's used in many large networks like Fastly, Lynx, CloudFlare, DigitalOcean, and yeah, there are many other companies using it out there, but their legal team didn't allow me to put them here. So why napalm? So if you have tried to automate a network that has multiple vendors, you probably ended with this spaghetti code that you can see on the left of the screen, where you say like, okay, if my network operating system is this one, I have to do this. If it's this other one, I have to do this complete different thing. So it doesn't really scale. You keep writing code just to deal with all the vendor differences instead of trying to solve the problem that you wanted to solve in the very beginning. So this is where napalm comes handy. Like you just solve the problem that you want to solve, because napalm is going to take care of all the particularities of the vendors behind the scenes for you. Here is an example where we are just getting data from the devices. You can see here that I'm doing it for a Juniper device and for an EOS device. And you don't know what's happening behind the scenes. You don't really care. You just want to know certain data from the device. You say, OK, give me this data. And you get not only the data, but you get it normalized. Like, for example, Juniper might give you the uptime in seconds since epoch, for example, while EOS might give it to you like in a formatted time, like 12 months, 5 minutes, whatever. So napalm not only takes care of getting the data, but in normalizing it for you. It's the same if you want to change configuration on the device. Instead of using PyC to deploy the configuration on the device, if you're using Junos, you just use napalm and it will take care of you of the configuration behind the scenes. Similar for EOS, instead of using PAPI, you just use napalm, and the same code that you would run for one device, it works on the other one. Note, though, that the configuration has to be syntactically correct for the particular vendor you're dealing with. Now, we also have OpenConfig support. And by this, what I mean is that we can actually parse a device configuration and return an OpenConfig object. So a lot of vendors keep talking that, yeah, now we have OpenConfig support, but that's pretty much marketing. You probably have in your network like iOS 12. Pretty sure that's pretty common here. And that obviously doesn't have any sort of OpenConfig support. So napalm can take care of that. Just parse the native configuration and give you an object. It can also do the opposite. Like you create an OpenConfig object where you put all your data. Like in this example, we're just creating an interface, setting the description, the MTU, configuring an IP, and then it can give you the corresponding native configuration for your device. So in summary, napalm aims to allow you to focus on what you want to do, not on how to do it. It brings also OpenConfig support now to all those vendors that claim to have it, but it's just pure marketing, or to all those old vendors that don't have it. And in Napalm, we don't want to pick sides. There is this war between, oh, should I use Ansible? Should I use Sol? Like, I personally don't care. Use whatever you want. Like, we integrate with anyone that wants to integrate with us. And this is all I had.
Great. Thanks, David. I'll take that. All right. Awesome. Good information there on napalm, and I'm sure that's something that you guys will want to dig into afterwards. All right. Coming up next, we have Jeremy from DigitalOcean. Jeremy, here you go. Take it away, sir.
Thank you. Hi, folks. My name's Jeremy Stretch. I'm a senior network developer at DigitalOcean. What that means is I have one foot in the traditional network engineering and another in, I guess, what you might call DevOps, which is basically developing applications in support of network operations specifically. You might know me as the lead maintainer of the NetBox open source project, which I'll talk about a little bit today. You might also recognize my name from packetlife.net, which is a blog I used to maintain. So what is IP address management? That's what I'm going to be talking about today. Typically, when we talk about IP address management, we're talking about number spaces on the network. So not just IP addresses, but prefixes, VLANs, route distinguishers, things of that nature. In practice, when we say IPAM, what we're really saying is anything that's important as a number or as an attribute of the network. So sometimes we'll extend this to mean, you might also see the acronym DCIM, or Data Center Infrastructure Management. And that entails things like physical connections, geographic locations for sites, rack elevations, and things of that nature. But for the purposes of what I'm talking about today, IPAM just kind of means all of that. An IPAM database should function as the authoritative registry in your network. What that means is anytime you need to know something about the network, this is where you should be going. We're very guilty across the industry for various reasons, whether it be organic growth or acquisitions or whatnot, for having many different sources from which we pull information. So you might have some sites that exist in a series of legacy spreadsheets, others might exist in a database, and it kind of depends where we should go. Ideally, you want to have that all on a centralized location, a central authority that everyone can both populate and reference. The form an IPAM system takes really depends on your organization and what makes sense for you. The most popular solutions are, obviously there are commercial and open source purpose-built applications. Other people take it upon themselves to build things in-house. And I'm sure a great can I get a quick show of hands? How many people still maintain either part or all of their IP addressing in spreadsheets? It's a safe space. You can admit it. It's okay. All right, not that many. That's good. That's good. A lot of people who have commented to me that have gone over to NetBox have said, we're coming from spreadsheets. This is actually enabling us to come from spreadsheets. I'm like, that's pretty crazy, because there have been IPAM tools out there for many, many years of varying degrees of adoption and maintenance. Of course, the final solution is also nothing. Some people are in a small enough environment where they just keep everything in their heads, and that obviously doesn't scale very well. The link at the bottom here is a Wikipedia page. You can go there. It has an entire list of, I think, just about all the known IPAM applications that are out there. It's probably close to, I don't know, 60 or 70 of them on the list. At DigitalOcean, we built our own IPAM system. I'll take a little bit of time to talk about why we did that. Like most companies that were very young, I've been with DO about 3 years now. When I started, everything was still in spreadsheets, I'll admit it. We started reevaluating the approach as we began growing more and more quickly, obviously, and they simply don't scale. As we got more and more people on the team, it became more problematic to maintain these things. We looked at the market and we looked at what was out there, and obviously there's two routes you can go. There's open source and there's commercial. What we found among open source solutions or options were some limitations, including lack of IPv6 support. So some of these applications had been developed many, many years in the past, and the author only really implemented IPv4 because that's all they needed at the time, and then it fell out of maintenance. It became unmaintained, so that's why IPv6 never really got added. The lack of VRF support also could be explained by many organizations, especially some years back, simply didn't need VRF support. They had no need for it on the network, so they didn't have the time to allocate to development, which is understandable. One of our requirements internally was to have something to track physical locations. Again, that's kind of that DCIM concept that I talked about. And many IPAM applications simply don't have that feature set. It's just not something of what they offer, which is, again, totally understandable. And of course, one of the most common problems in open source is lack of maintenance. Sometimes things simply fall out of maintenance because the primary developer most commonly changes jobs or has a life change, and they simply don't have the time to accommodate development anymore. On the commercial side, we have some different set of problems. The foremost, of course, turns out on the commercial side, people often want you to pay for things. Not that I have anything against commercial software, but the licensing structure of some products didn't make sense for us. We're a cloud hosting provider. As such, we have a huge amount of public IP space, as I'm sure many of you do in the service provider space. Unfortunately, when a product is licensed by volume, the vendor wants to capture the value that is provided by the application, which is perfectly fair. However, when you're a cloud provider, you have a huge amount of IP address space, but that doesn't necessarily mean it provides direct value to you. When we allocate things, we're doing it typically like a /20 or /19 at a time, and we're managing that one prefix. So it's a huge amount of space, but it's only one prefix, and some vendors still want to charge you based on the aggregate amount of IP space that you're managing, so that didn't make any sense to us. Another common thing was you have some commercial applications bundle other features with their products as well, which is great if you're more on the enterprise side and you need things like DHCP and DNS, but from the service provider / hosting side, those were extraneous, so in that case we're paying for something we don't necessarily need. And probably the most concerning bit for us, at least, was we didn't have a guaranteed opportunity to expand the features that we need. So if there's something in the product that we need, we wouldn't necessarily be able to do that. We can ask very nicely to whoever makes the software, but that there's no guarantee we'll actually get what we need to move forward. So our solution was this, NetBox. I started developing this internally late 2015, and it was open sourced in June 2016. And I've been blown away by the rate of adoption that we've seen so far. It's a Django application. It's built on the Django Python framework. It's a web application, has a REST API. I won't talk too much about it, but I'm going to give you an idea of what it is. NetBox was developed internally to be our source of truth. You probably hear that phrase come up more and more often. Jathan will talk about it as well. The thing that I always talk about whenever someone asks me about, well, what do you mean by source of truth, is every network has a desired state and an operational state. Very, very rarely will they ever be the same. By that I mean, the desired state is what you want your network to look like. The operational state is what your network actually looks like. The important thing to track here is, what do you do when they're different, right? Obviously, like I said, they're practically never going to be the same, but what do you do when they're different? That you need to have some authoritative source of truth that you can reference to say, no, this is how it's supposed to be. What's here right now is wrong. Because of that, maintaining the integrity of your IPAM data is crucial. This is going to be the top of the hierarchy that defines where everything should be, what should exist on the network. So if you go to set up a source of truth, you need to obviously get data in there. How do you put data into this? Let's say you find an IPAM solution that works for you, you set it up, and you say, okay, now what? Well, you have all this operational data from the network as it exists now. You have some documentation too, I'm sure, and you have your existing spreadsheets or a legacy application that you're migrating from. But how do you get data into it? There's a few different ways depending on the application. NetBox, for one, will support CSV import. This is great if you're moving from spreadsheets because it can more or less just take CSV and import it directly to objects in the database. Other common approaches are to use the REST API. This can be great, especially if you have this capability for webhooks or another API in your existing tool. You can program things directly through the command line shell. It's a very, very powerful tool if you sit down and learn like the Django ORM that NetBox employs, you can actually do immense heavy lifting with just a few lines of code. Or you can directly manipulate the database. I advise people against this because whether it's NetBox or a different tool, you don't really know the assumptions that the assumptions or the validation that the developer has in place necessarily, and you risk corrupting the data if you're manipulating SQL directly. The biggest thing here is don't blindly copy data from the network into the database. Again, this goes back to operational versus desired state. Just because something exists on the network doesn't mean it's supposed to be there on the network. Here's an example. This is a 4 by 10 gig lag between two switches. There's nothing wrong with this configuration. This will work. You'll get 40 gigs of throughput through this. However, if you were to take LLDP data from these switches and import it blindly into a database, you've now corrupted your database. You say, well, okay, maybe it's not a big deal, but what if in the future, months from now, you say, okay, I want to change this to independent layer 3 links? Well, 2 of them are going to break. Working with the assumption that they're connected in sequence. Obviously, it looks like 2 of the links have gotten swapped. It's funny because after deploying NetBox and using LLDP validation on our network, this is a very, very common problem that I've seen, is that we've whoever in the data center team was installing the stuff swapped links and nobody ever noticed because nobody actually went back to check because it was all working. Why does this fit into the theme of this talk today, along the lines of automation? Well, if you're going to deploy napalm, if you're going to use configuration templates, if you're going to script out, automate things, that data has to live somewhere, and IPAM is a great place for it to live. Not all of it, but you can get most of it in there. What goes in IPAM is things like device IP addresses, what platform they use, what napalm driver to use. Right? Napalm is an excellent tool, but to connect to the device, you have to know what it speaks. Right? Is it a Juniper device? Is it a Cisco device? You can put that in your IPAM. When you render device configurations, that data has to come from somewhere. Ideally, you can pull it from your IP address management system. You can look at NetBox or whatever your chosen solution is and say, okay, this interface is connected to this other interface. This is the IP addresses and the VLANs in use. And you can use it to validate operational state against desired state. For example, NetBox will act as a napalm proxy, which allows it to go talk by visiting, clicking a link. NetBox will reach out to a device, pull LLDP data from that device, and compare it against the database and highlight any inconsistencies. That's it. And that's one example of using a web interface. If you script that out or do something through the API, you can do that for an entire site at once, maybe daily if you want. That's the kind of gains that you get by having that data available. You just have to do the heavy lifting on the front to get that IPAM, and once you have a fully reliable source of truth, these are the kinds of things you can do. Real quickly, REST API is a great one to leverage. For example, in NetBox, you can pull up the API for a specific prefix. You make a POST request to the available IPs endpoint. It will automatically provision a new IP address within that prefix for you. So in summary, real quick, pick an IPAM solution that meets your needs and your budget. Always protect your source of truth. Always validate that data before you put it in there. Make sure there should always be a human at some point that looks at the data before it goes into a system. And leverage APIs where you can to tie in not just to devices and not just for scripting purposes, but also to other existing systems that you might have. Okay.
All right, excellent. Thank you, Jeremy. Lots of great information there. And continuing on the theme of the importance of having a network source of truth, we have Jathan McCollum from Dropbox to come up next. Here you go, sir.
Hello, I'm Jathan McCollum. Let's see, how does this thing work? All right. All right, so I am a network reliability engineer at Dropbox. What the hell is that? We pretty much formalized NetDevOps as a role at Dropbox, and really we're very spiritually connected to the SRE organizations, which you may be familiar with, which is basically a formalized DevOps role. So what does that mean? That means that we take software very seriously at Dropbox, and some of our new architectures are completely driven by software, which is going to be pretty cool. But anyway, we'll get to that later. I'm the maintainer of Network Source of Truth, which is something that we open sourced at Dropbox not long after I started there, and I took over that project. And Network Source of Truth is almost everything that NetBox is, except it's more stripped down. And we intentionally let Jeremy go first so he could get that out of the way so I can contrast what NSOT's approach compared to NetBox's. But anyway, I also maintain another project called Trigger that you may have heard of. It's a network automation toolkit that way outdates NetMiko and napalm and also shows its age in some ways. But it also does a lot of things that they don't, but that's not what we're here to talk about today. I was at NetEng at AOL for a very long time, almost 13 years. And then I went to Salesforce and ended up at Dropbox. So, what is NSOT? It is a source of truth database. NSOT is much more focused on inventory as a concept. What does it mean? IP address inventory, device inventory, interface inventory, circuits, coming soon as protocols. And so what we're really focusing on here is the ability to declare and define what you want your network to look like, and then use that data to drive configuration and whatever else in similar ways that Jeremy was just talking about. But most importantly, NSOT is API first, and that's one of the big differences between some other traditional approaches to network inventory and IPAM, and I'm going to talk about that. So, everything in NSOT is done using the REST API. That might sound terrifying at first. There is a web interface, but the web interface also uses the API. Nothing in NSOT has special database access, and that is an explicit design decision that drives the way that we do validation and inputs and the way that you interact with NSOT all the way through. So for example, if you wanted to go and put an IP address and create a new IP address entry, and then you give it a crappy IP address that's not real, it's going to barf at you from the server side, not the client side. And that's a very important relationship that you have with the application, because it allows you to customize your interfaces very well. And you know that if you get an error, the error is always going to come from the server. And the errors, the interface, the API for NSOT is uniform all the way from the top to the bottom, so that the errors look the same, even if you're working with, say, an interface versus a network. This also allows you, there's also a reference implementation of the API, which is the CLI. It's a Python library as well. So if you're a Python shop, it makes it very easy to get started using NSOT without having to worry too much about actually interacting with the API, because we've already done that for you. Similarly to NetBox, it's also a Django application, so it's we're using the Django REST framework, so it's allowing you to have a browsable version of the API, which is also very handy for engineers. And I think that, yeah, okay, so there's a couple of things that we really wanted to focus on, and one of which, I'm going to jump ahead a little, is feature parity in all of the user interfaces that we are publishing. Problem is that, just kidding, we're lying. The CLI is the perfect reference implementation of the API. Everything NSOT can do can be done from the CLI. The web UI has languished a little bit, and that's just because we had someone shift teams and their core strengths with them, and we were talking about rebooting the web UI. So if you go and install NSOT today, you will find the web UI does not do everything you want to do, and especially because networks are one of the core strengths of NSOT, and the web UI for NSOT is a little lacking in that area, but we'll get there. But one of the core principles here for NSOT is we want it to be really easy to set up and use. And literally, if you're familiar with anything with Python, it's really easy to set up. And another thing, too, is we wanted it to really be easy to get your data in and get your data out. Most traditional IPAM solutions out there, there's a lot of the open source ones, and especially the commercial ones, good luck with that. I'm sure that's why a lot of people use spreadsheets, right? Because you can do whatever the heck you want with a spreadsheet. But we also wanted to be flexible and customizable, and especially for our environment. At Dropbox is we move very quickly and things change, and so NSOT has this attribute value system that's very highly optimized, and also allows you to do almost whatever you want with NSOT in a lot of ways. Like it's, for example, the device objects in NSOT, which I'll cover in a minute, allow you could use it for hosts if you wanted to. NSOT doesn't care. And we actually have seen people doing that, and I'll talk about that too in a sec. Last thing is loose coupling. What does that mean? We want to be able to horizontally scale any part of NSOT. We don't want to be tied to PostgreSQL because we're in a MySQL shop. You can use SQLite if you want to. Some people are using SQLite just because it's easy. You can set up whatever web front ends you want, whatever, you can do caching. There's all kinds of extra things that you can do with NSOT that don't come out of the box. The data model is pretty linear. And we're starting from the top to the bottom here. What we're trying to do with NSOT is NSOT's really invested in being a desired state vehicle. You can use it for discovered data if you want to. We've seen people do that. But that's not what we're using it for at Dropbox. So sites, we have it at the top level. Might not be sites in what you think of. They're namespaces. Namespaces, basically, you can have overlapping objects. You can have different groups of network objects, for example, that conflict with each other. So at Dropbox, we're a one-site shop. We're not using that feature, but it's there. Attributes and values are really where the flexibility comes in. So when I said that NSOT is a bare-bones solution, it is. It doesn't come with any predefined attributes or values. So if you think on a device, like what's the most common attribute that you probably have? A vendor, hardware type, those kinds of things. You're going to have to populate those yourself and create those yourself. The device, for example, by default only has a host name. But then it goes to network. So like, devices, you connect interfaces to devices, you attach networks to interfaces, you bind interfaces to circuits. These are all things that we do in the real world. This is exactly how they're modeled in NSOT. Lastly, changes. Everything that you do in NSOT is logged in a change log, and there is coming soon the ability to roll back changes and restore objects to a previous state. But that's not really there yet. I think I kind of skipped around. Like I said, you can use NSOT however you want. It's as minimally opinionated as possible. One of the other really cool things is the ability to do set queries. This is something that at first seems a little weird, but it's actually very powerful. So based on attribute values, you can do unions, intersections, and differences, and it starts getting really mathy there, but actually the way we've expressed it with text is actually pretty cool. I'm not going to get too far into that right now. I just wanted to raise the point that set queries are a very powerful way to, say, limit. You could say like vendor equals Juniper minus hardware type equals switch to get all Juniper devices that aren't switches, for example. So it's kind of a very expressive way of filtering queries to look things up. That's kind of it. This was kind of meant to be like a hard and fast introduction to NSOT, but it's fairly well documented, and there's the Python client. It also includes the CLI utility. And we do hang out on the Network to Code Slack, and we're also on IRC on #NSOT. And that's it. Thanks.
All right, awesome. Thank you, Jathan. I'll take that from you. Okay, and to wrap things up and close us up, we have Mircea, who is going to be talking about some event-driven network automation stuff. And I would just remind you, keep your eye on the time.
Yeah. Hi, my name is Mircea. I'm a network engineer at CloudFlare. I'm also a member and maintainer at the Napalm automation community together with David and Kirk. I've integrated the Napalm in Salt, and I'm also OpenConfig representative. And sometimes I blog at my complicated name .net. And today I will have a very brief introduction to event-driven network automation, because there's a myth saying that network automation is only about configuration management. But I can't agree with Mr. Abraham in this context, and I will try to prove how false is this affirmation. Because we have plenty of events happening around our networks. They can be internally or externally. Some of the most common ways internally your network is trying to communicate with you is through SNMP traps, syslog messages, and the new kid streaming telemetry. And it's about millions of messages your network is trying to communicate with you. So let's take the first two, for example. SNMP traps, they've been there for years, but most of people have been using them only as notifications, like, hey, you have an interface down. Okay, thanks, I'm going to apply manually a configuration change now. Or in the last few years, I'm going to run manually a command that is going to do what it has to do. But you see, the pattern is still manually. Syslog messages, most of people don't use them at all, or they store them somewhere. They're on the server somewhere. I don't know where the server is. Or some people may probably use them as some vague notifications. But there's plenty of important data in those syslog messages. They can give you details like an interface is flapping, or the optics level is below the threshold, or chases alarms. NTP server is down, so your network is unsynchronized, or simply BGP neighbor is leaking their entire routing table to you. So, do you really want to ignore this data? About streaming telemetry, while SNMP is about pulling data at specific intervals, streaming telemetry is the opposite. It's the device will push you notifications when it has something to tell you about. And these notifications are usually structured documents which are, their hierarchy follows the Yang models. There are two main organizations that write these models. They are OpenConfig and IETF. Although I'm a very big fan of streaming telemetry, this is still supported only on very new operating systems like iOS XR. You need 6.1.1, while many people are still running 4. something. Or Junos 15, at least 15.1, but that depends on platforms. There are some platforms that have it only on 17.1, which has been released only a couple of months ago. And even so, the variety of features is not that big. Let's go back to the syslog messages. I have here two snippets of syslog messages from Junos and iOS XR. Although they present exactly the same notification, where saying that an NTP server is unreachable, they look totally different. So this is why in the network automation community, we decided to normalize this as well, as we do with the other parts that David has already presented. And napalm-logs is an engine that continuously listens for syslog messages, either from the network devices directly via UDP or TCP, or through different systems like Kafka or ZeroMQ and so on. Then napalm-logs will compute a document that is structured following the same Yang models from OpenConfig and IETF. And these structured documents are then binary serialized, encrypted, signed, and published over various channels like ZeroMQ, Kafka, and so on. To visualize this, in the center is napalm-logs that is continuously listening for messages from the network devices or pulling them from Kafka. And will publish the structured documents to Kafka, ZeroMQ, and so on, where various clients can connect to and retrieve those documents. From the examples I had previously with those two snippets, napalm-logs will produce a message like this one that is structured following the OpenConfig system model. And doesn't matter if you receive the notification from iOS XR, Junos, EOS, or so on, the document will have exactly the same structure. It's system NTP servers and tells you that 172.17.71 has a stratum 16. That means it's unreachable. As I said, there are various clients that can connect to collect those the structured documents. You can either connect directly to consume them, or using a very well-known framework like Stackstorm or Salt, how I'm going to exemplify. Salt, for who is not comfortable with, is data-driven automation framework. And anything happens if you run a command on the CLI, it's going to be, will go to an event bus. If you, for example, run net.arp to retrieve the ARP tables from a device, you will see an event like this on the bus. Each event has a unique tag that identifies the event, and the event has also a body. One of the clients that are already embedded into Salt that retrieves messages from napalm-logs is called an engine napalm-syslog. It's very easy to configure. Only say you'll consume messages from napalm-logs running at this address at this port, and we'll import them on the Salt bus. And importing means that we'll have exactly the same body, but we'll also assign a tag for this event. And this tag somewhere at the top is napalm-syslog /JunoS because the message has been received from a JunoS device. Then a unique label of the message, NTP server unreachable, and at the end, the last namespace is the hostname of the device. The slash is between two consecutive namespaces. At the end, we can fully automate your configuration changes. For example, you can uniquely identify your events using, for example, the reactor system. And when you have a message that has the pattern I just exemplified, you can match it with the reactor. For example, you say match when you have an event from having the tag napalm-syslog, then followed by anything, then NTP server unreachable from any host name, you are going to run this command that basically is the equivalent when you would run from the CLI manually to deploy a configuration change. And this can be extended to any kind of events you want to match and to trigger in your network. Is the myth busted?
All right, great. You keep that. Thank you, Mircea. Appreciate it. All right, so you've just heard from all 5 speakers on various aspects of network automation. I'd like to take a moment now and see if anyone has any questions they would like to address to the panelists. So let's start here in the middle. Go ahead, sir.
John O'Brien, University of Pennsylvania. This has been a fantastic panel, and I'm going to try to constrain my enthusiasm for questions. One of the sort of intrinsic challenges that we've had in my environment is that while there are sort of clear technical measures to facilitate the provisioning of resources, it's kind of hard to make sure that people clean up after themselves and that things are deprovisioned and that that's reflected in the sources of truth. Can you comment on strategies that you've found successful for that?
Okay, let's get Jeremy and Jathan to jump in on that.
I'll take this one for a sec. Delete it from your source of truth. It's not easy. I think one of the strategies is you have to have a good life cycle, like a pipeline of like how things get in and how things go out. And a lot of times, like what we've done at Dropbox, for example, anything that goes into NSOT is tied to physical hardware. We're not still good about deleting things from NSOT yet, although I'd like us to. So what we do is we have an attribute in NSOT that represents the actual state of the hardware. Right now, it's still a little bit overloaded, but that's a good strategy, right? You can say like the state of this device is decommed versus the state of this device is in production, and then that's something you can filter on. If you don't want to delete stuff, that's actually a really good starting point.
I'll just add that in NetBox, one of the approaches that we've taken is work I'm doing right now on a feature called validation reports. It's contained in the version 2.2 beta if you guys want to go take a look at it. But basically, it amounts to, remember, you have this data available. You can leverage tools like Napalm, which is built into NetBox, and validate the network against that. You can actually reach out using Napalm, say, all right, give me all of your, go talk to a Juniper router and say, give me all of your IRB interfaces that have an IP address assigned to them. You pull that data in, you match that against what's in NetBox. You can flag on anything that's not supposed to be there. Whether it was there and it's not in source of truth, or it was and somebody decommissioned it, you can do that. And you can have a report that runs at the end of every day that says, what's everything that's not supposed to be, every IP address or VLAN that's not supposed to exist on this. And you can actually email that to your team or however you prefer to have it delivered. That's the approach I would take.
Awesome, great, thanks. Let's go over here. Yes, sir.
Yeah, Ryan Datalink, networking enthusiast. From a beginning developer standpoint, and I'm not trying to start a holy war here, Python 2 or 3? What tools are you guys developing in? What should we be learning?
All right, Kirk, you want to jump in on that and then have somebody else follow up?
Yeah, so I think we've really reached the point where Python 3 is at parity, so I really wouldn't, I think you might as, at this point, you might as well just do Python 3, that you're not going to run into too many obstacles doing Python 2. And for a lot of things, especially for a beginner, the delta is not too big, so I would just start with Python 3 at this point.
Cool, good enough, thank you.
All right, go ahead, sir.
Adam Mills from Roblox. I had some questions for the gentleman who presented about the DCIM products. both of those products seem to be very network focused. How do you guys address the 50 or 60 other devices that are in the racks? Do you guys track those? Do you have to separate and have two different sources of truth for both of those products?
So in NetBox, you can import anything. It doesn't have to be a network device. It can be a power supply or a PDU. It can be a console server. It can be a server. Anything. You can create as many device types as you want. You can find manufacturers and hardware types. You can add. NetBox at least supports console ports, console connections, power connections, and data connections. So you can have pretty much anything that goes in a rack. You can put there, whether it's rack mounted or not. The only real limitation that we have right now is around furniture, so like patch panels and shelves and stuff like that we don't really do a good job with. But anything else, was there like a specific type of device that you had in mind?
Just the rack-mounted servers. So like right now we're in the process of evaluating a couple of different DCIM products, Device 42, you know, some of the big name ones. It's really intriguing based on the APIs and stuff that you guys have. But you know, at previous companies that I worked at, there was a very tight coupling between, you know, the guy who's racking the servers, does he enter in the devices properly, and then that, you know, that kind of kills automation. And you know, if the teams don't work together. So I was curious if you guys had broken, because I know DigitalOcean and Dropbox, you guys have a huge server footprint globally. Are those in the same system? Like if you have a failure on, you know, port 43, do you know what that is?
We're getting there right now. Right now, we in our instance of NetBox, we're only doing the network engineered stuff. However, we're adopting it on the data center side as well. Our DC team is using that. It's just a matter of importing everything into the new database and how we're going to do that, because part of that, unfortunately, it's the one thing you can't automate is rack elevations. You need someone to physically go there and look at, take a picture, where is everything in the rack? There's no way to get that data outside of a human. So that's kind of the slowdown or the choke point right there. But yeah, you can put everything in there, and you can actually assign permissions to different teams so that only the data center team can manipulate a server, only the network team can manipulate a router, if that's what you want to do.
Short answer, Dropbox has two systems for that.
Thank you.
All right, go ahead, sir. Thank you.
Marco Marzetti, PCCW Global. This is a question for David and Mircea mainly. I wonder, how do you deal with those commands that do not fit into OpenConfig for whatever reason? I know that there are, the OpenConfig models are huge, cover a lot of parts of the configuration, but there are some commands that you cannot parse and you cannot put it into OpenConfig, and I wonder how napalm works in that way.
So if we're going to talk about the Yang integration with napalm, the idea is that I mentioned OpenConfig because that's what everybody knows about, but the idea is that it's integrated with Yang models. So it could be an ITF model, it could be an OpenConfig model. So if there is something that is not supported by either the OpenConfig community or the ITF, I mean, it would be a matter of bringing the topic to them, see if they want to fix it, or otherwise just write our own models for that. So that's fine. There is an example already. We're using the IP model to manage, well, the IP addresses associated to the interfaces. And the OpenConfig model doesn't support the secondary keyword that you need in different platforms. So we extended the existing model with that keyword so we could have it in napalm Yang, because we needed that to be able to do the translation to native configuration in platforms like iOS or iOS.
Thanks.
Okay, go ahead.
John O'Brien again from Penn. Penn is very organizationally decentralized, so even though our enterprise network is called PennNet, you might as well call it BYODNet, or the network of unmanaged devices. One of my pain points has been trying to monitor and mine MAC tables, ARP tables, and neighbor tables because of what seemed to me to be kind of clunky and inadequate support on the vendor side. Is this a problem that you've encountered, and what sort of solutions do you have for it?
Yeah, there are a couple of ways to do this. You can continuously monitor the size. So basically, you are interested in the size more specifically, or what you have inside those tables?
Well, I've encountered both those problems. The size, I basically got to ingest the whole thing to count how many are in the table, but also just sort of monitoring over the course of time which IPs and MAC addresses have been active over time and where.
Yeah, in order to determine what IP address is in the tables, you need to continuously retrieve this data. But if you have too many addresses in these tables, I know for sure that there's a syslog message that tells you you have exceeded the maximum number you have set or what is set by default. And you can use this for example, as I exemplified with napalm-logs or what other tools are available. And I think I have a pull request over the weekend. Someone just added exactly this and will be available for the MAC address tables in the next release of napalm-logs.
And I would add to that napalm does make it easier for you to pull the MAC address table and the ARP address table from multi-vendor, and that we have normalized, including done the screen scraping on some legacy platforms so that you just get basically a data structure back that says, here's your MAC addresses, here's your ARP table.
Okay, great. Thanks, guys. All right, we have time for one more question. Unfortunately, the other two guys in line, I'm so sorry. I'm sure if you grab one of these guys during the event, they'd be more than happy to talk with you. So go ahead, sir.
Hi, Jason Bell, network engineer. My question's going off of Kirk's comment about being too busy to learn automation and try it. So in all of your experience, what network operations is an interrupt-driven job where something breaks and someone pings you or you see an alert. So how do you do the critical thinking that it takes to do these more complex problems doing coding, where if at any time you might be pulled into an escalation or something like that?
Yeah, and so I think this is why in a lot of times in a lot of the DevOps events they talk about organizational things, that I think there's a lot here that has to be sort of embraced at an organizational level, and that I think an organization sort of has to realize if they have everybody at max capacity, that it's a failure scenario. And there's really good books on this, the Phoenix Project and the Goal, where they're exemplifying this pattern of you're operating at 110% and you're in this constant chaos and firefighting mode, and then a year down the road you're still in that. So I think you as an individual, you can bring it up and try to tell people that, hey, we need this extra time so that we can start improving our processes, improving our systems. But ultimately, the organization has to embrace that is net valuable for you to do, to give you that, or else you're going to have real struggles in order to enact that.
Okay, and that's it for time. So let's give these panelists a great round of applause and thank you.